Cool. Well, it's great to be here. Thank you so much for having me. We've heard a lot this week about amazing new innovative technologies that are coming out, things that you're going to want to use for your business in a year, in 2 years, in 3 years. My question to you is this: who's going to be building the technologies in 5 years, in 10 years? How do we keep up that pace of innovation? And how do we use the technologies like Devin AI? Who's going to be using those, right? It's the senior software engineers. So how do we build up that workforce? That's what I'm here to talk to you about today. As Nan said, I used to run a venture-backed tech startup, and I also was an AI researcher and an AI engineer. I am also, for the last 10 years of my life, I've been working on this problem with education. And I am the editor for a leading technology education research journal. So basically, I know a lot about AI from the business side. I know a lot about AI from the research side, and I know a lot about AI from the education side. And I want to talk to you a little bit about the problem we're facing and how we can all work together to solve this. So there's a problem. As you may know, there is a global talent shortage, right? 4.8 million cybersecurity professionals is the estimate of what's needed right now. 4.2 million AI developers, 2.1 million network engineers. I had a recent conversation with the CISO who spent 8 months trying to fill a security engineering role that was really key to their team. We went to a conference for recruiters recently, big tech recruiters. They are currently recruiting students for interns and new grad roles a year in advance. So people are being recruited in May 2025 for roles that are starting in June 2026. That's how competitive it is to access the top new grad talent. At the same time, this is a recent New York Times article you may have seen. Goodbye $165,000 tech jobs, student coders seek work at Chipotle, right? A lot of graduates now are having difficulty getting jobs. So this is the paradox. New grads can't get jobs. Senior grads are in more demand than ever. This is some data from comparing this year's hiring to last year's hiring at big tech companies. New grad hiring is down 25%. 2 to 5 years and above, it's up. Right? This is the problem that we have. Millions of students are graduating. Companies can't find talent. Students can't find jobs. So it's pretty clear that something is wrong here, right? We've heard for the last decade that the problem is that there aren't enough students studying computer science, IT, all of these fields. That's what we've been hearing. What if the problem isn't the quantity, but the quality? What if it isn't about the number of students graduating, but how we're preparing them? You've heard of the experience gap, right? The experience gap means that when a student graduates, they walk out of their college, they walk into your door, it takes them, on average, about 12 months to become productive. That means that companies are wasting somewhere around $50,000 to $75,000, and it's getting worse every year because complexity is growing exponentially, right? The complexity of software and network infrastructure has grown exponentially since the 1900s, and especially since the 1990s. And it's combinatorial, right? When we build something new, we do it by combining previous existing technologies, but that means it grows exponentially in complexity. So technology is evolving in weeks, and it's getting more complex. Curricula evolves in years, and there's only so much you can fit in a 4-year degree. So we cannot teach our students every single skill they could possibly need to know. So despite all of this complexity and despite the problem that new grads are having, senior software engineers are still in high demand, right? All of the senior level people are still in demand. The job safety of everyone in this room is hopefully pretty secure for quite a while, right? So what is it that everyone in this room knows, that all of your best people know, that the students don't know? So we actually went and we asked them, right? We talked to 480 hiring managers, and we asked them, you're working day to day with these new grads. What are the skills that they need to know? What are the skills that your senior level people know that are most important for working with AI tools to build these innovative new technologies collaboratively with AI? And then what is your current ability of new graduates in those skills? And we combine those two into the impact, right? What are the things we can do that make the biggest impact here? We came up with 6 of them. Initiative, technical communication, product sense, problem solving, curiosity. 5 out of those 6 core skills that are what all of the hiring managers and the people working day to day with these people know, 5 out of those 6 are not things that are taught in schools. The only thing that's taught in schools is domain knowledge. It's the very specific things that you need to know. And as you all know from coming to conferences like this, that changes quickly, right? What you need to know day to day changes quickly. The average half-life for a specific skill is about 3 to 5 years. So what if we can make all the other 5 a core part of the education? And that's where everyone in this room comes in. That's where we're trying to bring together industry and education to close this experience gap. So what could that look like? One example of this model is what we call an open source internship. I think most people in this room are probably familiar with what open source software is, but if you're not, here's some examples. Kubernetes, the operating system for cloud computing. Firefox and Chrome, used by 70% of web users. Android with 3 billion active devices. And Linux, which powers like 97% of all the servers. All of our students have actually contributed to these projects. We literally have code running in Linux that was shipped from undergraduates who are new to this whole thing. Our smallest partner project is actually a project called F-Prime, but it's got 1 user. But the 1 user is NASA. It's the operating system that runs on their space hardware. So students have literally shipped code to space. All of these projects have a problem, which is not many people are maintaining them. If I don't put this image up on slide, someone always tells me about it afterward. Have you seen this comic? All modern digital infrastructure is sort of Jenga stacked on top of a random project that some guy in Nebraska has been thanklessly maintaining since 2003. So these projects are asking for help. They literally are tagging things with like a good first issue, help wanted, up for grabs. They want more people. So we partner with academia and industry, and we said, well, let's solve both of these problems at once. So we put together a team with our school partners of 2 to 4 students, and they work on one issue. We give them an industry mentor, right? Now, the industry mentor, we don't want to cost industry, again, $50, $75, $100,000 in investment to train someone, right? So the industry mentor is only putting in about an hour a week for 4 weeks. How does that work? Well, the idea is rather than having a subject matter expert who's coaching students on how to do everything in a great amount of detail, instead of that, we give them an industry mentor who has no idea what problem they're working on. And they're just a peer to them. They're a more experienced peer. And the students come to them once a week and they say, here's what we think we figured out. And the industry mentor then says, yeah, that's interesting. I don't know how that works either. Here's how I would approach that. Or yeah, your thing sounds 90% right, but like let's check into this one thing and see if it works. So providing them the ability to develop those higher level skills while they're working on a real issue. We also, at CodeDay, the nonprofit that I work for, we provide them with TAs, and we also connect them with community support from those projects. The key thing about this model is this. This is 4 weeks. It is 10 hours a week that the students are putting in. It's 1 hour a week that the mentors are putting in. It starts out pretty simple. What technologies are you using? What framework are you using? And then we move into the more complicated stuff, like building and finding starting points, which is places in the code that you might look to try to do what you're trying to do, because schools only teach students how to build brand new code bases from scratch, but most of us are not hiring new grads to build a brand new code base. It gets more complicated over time, and the students do struggle with this. We actually see that when we polled some mentors just for seniors who are about to graduate college, we polled mentors, how hireable are they as a new grad? They started out not great. It was like 55%, and this was back in 2020. And it actually got worse for the first 2 weeks. The students were less hireable after 2 weeks because they really struggled. But what we saw was that over the course of this, the students actually improved significantly. And we ended up with about 80% of students being rated as highly hireable by their software engineering mentors. The mindset shifts. And the thing is, this is just 4 weeks, 10 hours a week. So the goal is we need to put these sort of interventions at every stage of education, right? We started off with college seniors, we moved to college juniors, sophomores, freshmen, and we're moving into high school programming that is focused on these real-world open source contributions, because we need this to be a part of education the entire time, and we need to all work together to make that happen. These students are also reflecting on what they've done. If you go on LinkedIn and you search for micro-internship open source, you can find hundreds of these blog posts of students talking about what they've learned from this process, which is honestly just really fun to read, but a great thing for hiring managers to look at when they're evaluating whether a candidate can do this. So working together, we have been able to get 5 out of these 6 areas of competency that schools have traditionally been bad at. We've been able to get those into the curriculum in a significant percentage of the colleges in Washington State, all of the publicly funded schools, colleges in California, and even 2 of the CUNY colleges in New York, and we're continuing to grow this together. with our industry partners. We know that this works because we've had over 1,500 open source software contributions that have been successfully merged. If you are using any technology, you're using software written by our students today. We've had over 500,000 hours students have put into this, 20,000 hours of mentorship. This is an example. It's hard to find an example of a cool open source project that's fun to visualize the outcome with in networking or a lot of other things, cybersecurity. We've had students do security audits on popular code bases as an example, but here's one example that you can really see. This is actually visualizing the data format that self-driving cars produce, visualizing that on a popular open source mapping program. OK, so we know that these students work because we've had so many of them go through it, and they are 2.5 times as likely to get a job as their peers within 6 months. They're onboarding 3 times faster, and what we mean by that is they are moving from a new graduate up to a mid-level or a senior level engineer 3 times faster than someone else who was hired at the same time. We've heard that from our employer partners. Conservatively, we're saving companies by bringing industry into the education stream in a very small way. We are saving companies conservatively about $50,000 a year, and we think it's more. This also opens the door to a new class of students. When you think of the best of the best right now, where are you going to go? MIT, Stanford, Berkeley, some of those colleges, right? But if all of the students are getting this experience throughout their entire education, we're getting students that are not just your standard 20, 21-year-old graduate from MIT who you're going to be hiring. If you're building a cell phone company, who better to help you build that than someone who used to sell cell phones in your store? And actually, one of the people on our board is former VP of engineering at T-Mobile, and he hired a lot of students from us and had that exact experience. They understand it. We talked about product sense. If you're going to use an AI tool like Devin to build the future of innovative technology, what better than someone who used to be on the receiving end of that technology, the people who used to use it day to day? So also, if you want to hire someone, for example, for like a reliability role, if you're worried about your network going down and you need someone who can fix it really quickly, do you want a 21-year-old grad from MIT, or do you want someone who's a former Navy veteran? Right? Talk about someone who's going to be really cool under pressure. These students have grit. They're very unusual people that you would not normally meet, but because of that, they're going to be the people who have the most creative ideas that are really going to be leading the innovation of tomorrow. So what I want to leave you with is this. First of all, if you're interested in how your company specifically can get involved with trying to bring more initiatives like these micro-internships, these open source micro-internships into schools and get more talent, please come find me. I'd love to talk to more folks. I'm also just interested to learn more about what you see as the skills that students need. And moreover, I hope that everyone in here will think about how your company is engaging with education and basically building the workforce of tomorrow. Because if you don't, a lot of people in this room and a lot of people who work for you are going to retire soon, certainly within the next 5 to 10 years. And when that happens, who's going to be there to replace them? It's not going to be the new graduates who are just getting the standard education that they're used to. It's going to be people who know how to work with these AI tools to build things. So again, thank you so much for having me, and I hope to talk to some of you more about this. Thank you.